Hey mathematicians, here are notes for 4.6 talking about functions, and this is going to be a 2-day thing. We're going to start off really simple today. We're going to get a little bit more advanced tomorrow. So let's start off with that bell work. What is the definition of a relation? If it's your definition, if it's the definition from a few days ago, totally fine either one, but I want you to have just a little refresher in that. And then what are the 3 forms a relation can be represented by? So go ahead and take a minute, write those down, fill that out, and then come on back, we'll talk about it. Alright, from a few days ago, my definition of a relation was a set of ordered pairs or related x and y values. And that is, that's a pretty general definition. Notice that's a very loose, there's no, a loose definition because there's no stipulations. X doesn't have to be a specific relation to y, you don't have to have a specific number, anything like that. Again, very loose definition. The 3 forms a relation can be represented by. Well, you've got the table. That one's the simple one. The graph. Remember where we graph those ordered pairs. And then we have the map. That's the 2 ovals that we create with our x in one and our y in the other one. Today's goal is to be able to explain the concept of a function, and this is very minimal explanation. Tomorrow, a little bit trickier. A function is a special type of relation. So if your relation is your umbrella term, function is something a little bit more specific. And the thing that makes it special is that it is a relation in which each domain, aka each x value, wow, I'm struggling, each domain has exactly one range value, so y. So an example of this would be 2, 3, 3, 4, 5, 7. Ha, you thought I was going to go 4, 5. Tricked you. But notice, each x value has its own range. I don't have a 2, 3 and then a 2, 4, because that would mean that the domain has a 3 and a 4. That would give it 2 ranges, but that's not a function. So let's look at some more examples. Let's get more in depth here. So an example of a table, and I'll leave room if you want to do another example on your own to see if you get that concept, would just be something where they're all individual. Notice, if all the x's are individual, all the y's can be individual. I don't have any numbers where -1 goes to 3 and 4, -1 goes to 5, anything like that. It's just one x gets one y. A set would be -4, 6, 5, 1, 3, 2. Again, your x can't repeat. That's all it is. That's the only thing that makes this special. I think it's most often easiest to see a function in a mapping. I'm not even going to put numbers in here, because in a mapping, it does not matter what numbers are there so long as each x has its own y. So you can always just see that they should go either straight across. They can, I guess I could have put like one that goes across, but again, each x has its own y. It might be a little bit easier to see when things are not a function. So which of these is not a function? Well, if we look at this one, remember how I said each x has exactly one y. Right off the bat, this table is a problem because -2 has -7, but it also has 5. That means that -2, the x, has 2 different y values, and we do not like that. So this is not a function. In case you don't see it there, just the number 2, not -2, also has 2. This is the shape. Yeah, let's say shape. This is the shape of arrows that we do not want when we're looking for functions. We don't want one number in the x column to go to two different numbers in the y. We don't like that. This is sad face. In a set, it's a little bit harder to see, but again, we're looking for the same thing. Do we have any repeating x's that go to different y's? We do. We have a 0 that goes to 5, and we have a 0 that goes to 8. If I were to draw that in a table, again to look for that shape, I would have a 0 that goes to 5, and I'd have a 0 that goes to 8. I don't like that shape. That triangle or those double arrows don't work. This is why I said it was easiest to see in mapping, because right off the bat, we see that arrow that we don't like. This map says that I have 0, 5 and 0, 8. It goes to two values. So both this set and this mapping are not functions because they have a repeating 0 that goes to different numbers. Get that down. If you have any questions, let me know right away, because when we flip to the back, it's going to get just a little confusing, just for a minute. Big important note at the top. Crazy big. I tried to make it so you could see it. Y coordinates, stuff on the right-hand side, can repeat as long as they repeat with different x coordinates. So notice, 7 goes to -2. That's okay. But -2 goes to -2. That is also okay, because notice, these are not repeating x's. They're each domain has its own range. That's okay. There's no repeating x's that go to different values. So, notice, -2 could go to 7 and -2 could go to -2, but that would not create that shape that we dislike. So that is why we're okay with that. All right, this is another big concept, something called the vertical line test. We're going to use this a lot this year, and it's going to come up a lot in math classes after this. So what is it? What is the vertical line test? It basically says this. If any, maybe I'll just write it and then I'll read it. Oh, I ran out of room. That's okay. All right, let's read this here. If any vertical line crosses a graph more than once, then the relation is not a function. So, on the left, we have an example of a function. Ignore this f of x. We have not dealt with function notation yet. Another way to look at that would just be, it's just saying that's the y. So if I have some random coordinate, if I take my pen and I create a vertical line, remember vertical up and down, not horizontal side to side, and I trace this line that is representing a relation, notice at any given time, my pen is only crossing this line one time, just at that exact spot. So if I move it, it hits here, it hits here, it hits here, it hits here, etc., etc., etc. But it never hits twice. So the vertical line test tells me this is a function. However, if I go over to this circle and I do the same line test, when I first hit the edge of the circle, sure, I'm only hitting it once, but as it shows in this picture, when I get a little bit farther in, I start hitting at multiple points at the same time. Therefore, by the vertical line test, this is not a function. A circle is not a function because it crosses more than once. Let's look at these next few. If I take my pen and I do the vertical line test, I say, is this line here on the coordinate plane a function? It hits 1, it hits 1, it's not crossing, it's only hitting at one point. I can do that. I can even put some little dashed lines down through here to show you, yep, it's only ever hitting that line at one point at one time. So is this a function? Yes, it is, based on the vertical line test. However, the next one, if I do the same test, sure, it's okay until we get to about here, where we don't just hit 2 times, we actually hit multiple times, and I'm going to draw that line in. If I do the vertical line test right here, I hit 1, 2, 3 different times. If I do it here, I hit 1, 2, 3 different times. So based on the vertical line test, this is not a function. Go ahead and try that last one on your own. Do you think it's a function or not a function based on the vertical line test? All right, after trying it yourself, you should see that yes, it is a function because at any given point, we're only crossing that line 1 time. So, big recap. Function. Every x has exactly 1 y. Y's can repeat as long as they have different x's. The vertical line test says as long as it only hits the line once, each time you move your pen, it is a function. This has been a really broad overview. Tomorrow we're really going to start playing with the numbers and getting a little bit more advanced. So if you have any questions on anything we went over, let me know.